just telling you a bit of feedback what I received. So this is continuing from what we left. So one thing is, this debate will possibly continue, that which is more useful, Facebook or Twitter data. But I must say, as researchers, disaster is a situation where information is sparse. So whatever information can be obtained, we should aim to target it or use it. Therefore, it makes sense to collect from as many sources as possible: Twitter, Facebook, WhatsApp, anything, and then try to collect and check more data. Because getting data from different sources can be more confusing, but also can help to, like, maybe something is missing on one certain on one medium, which can be obtained from the other. So there is nothing which prevents people from trying to collect data from different sources. The other thing is about rumors. It's very difficult to figure out rumors. I have just one slide on it, but basically that will say nothing except the problem, maybe. But there is no well-known rule which will affect or which will help us to distinguish between rumor and correct information. To the extent that there are some rumors which are posted even by very important people. For example, during the Paris attacks, there was one of the Belgian ministers was giving an interview, and there he claimed, or one of the Belgian ministers gave an interview, and after the interview, lots of even media organizations started reporting that the Belgian minister has said that the terrorists were using Sony PlayStation to communicate among themselves during the attack. So Sony PlayStation became a buzzword on Twitter, that people are using, or the terrorists were using Sony PlayStation to communicate among themselves. And lots of media organizations also reported this. After maybe the next day, it was clarified by the minister himself. I did not mean this. What I meant is that if people use advanced technologies like Sony PlayStation, which we believe some terrorist organizations are using, then it is very difficult to track. But I never claimed they were used during this Paris attack. So you might say this was false information, but then this is a very subtle kind of false information, because even the news media people who were actually present during the interview were reporting it. So this was mainly just a miscommunication. But yeah, like none of the techniques, like for example, we were discussing about one technique. What if we rely only on very reliable people, like journalists? But even that is not true. And another thing is latency versus accuracy, like pointed out, the relationship among latency and accuracy is just not that you can choose one over the other. Sometimes it can be that with increase, if you delay giving your insights, the accuracy can fall. Because the situation, accuracy can become even wrong. The accuracy may fall because the situation has changed in the meantime. Right? So latency and accuracy has complex relationships, and again, these are our research challenges. Right? I don't have an answer to exactly what is meant. And frankly, if these questions are already answered, maybe there would not be this workshop or this tutorial. So these challenges remain. Okay, so we have talked a bit about collecting data from Twitter. Now let's focus on how to process this data. So when processing this data, I'll just point out some ready-made tools which you can use, like natural language processing tools, which can be used to figure out, to extract information from social media posts. I must say that it's not that I have used myself all these tools, but I have seen these tools being used in the community. And that is, so if anyone is interested, you can read these, you can go through these tools and use them. So, one of the seemingly very simple, but not so simple kind of processing things are deduplication. So the same tweet or the very similar tweets are posted even hundreds of times. Maybe some very popular person has posted a tweet that will be retweeted thousands of times. Or maybe even the same information is being posted by multiple people. So the same tweet or very similar tweets are being posted multiple times, and they may need to be ignored. I say may, because for example, suppose your application is figuring out popular content, then you do not want to ignore repeated tweets, because the more the content is repeated, the more popular it is. However, suppose your application is summarization. You are trying to build up a summarized snapshot of the information that is being posted, then you would want to remove duplicate tweets, because summary duplicates have no place. You want to remove duplicate tweets and only focus on the distinct information which is available. So this paper in November 2013, this gave different ways of figuring out very similar or near duplicates among tweets, and they also have a dataset page where they give some tools and datasets. Okay, take a look. So this is a seemingly trivial challenge, but it's not so trivial. Because remember, the same information can be worded in slightly different ways. Right? So, and because of the length limitation of Twitter, there are further complications. For example, someone says more than 40 crocodiles out on Chennai streets. Another person wants to give the same information, but he wants to give some additional information. So he just says 40 plus crocs on Chennai streets. The crocs and crocodiles, for a human being it's easy to understand they are the same, but for a machine it might be not so easy. So these kind of challenges are there. Then some common natural language processing tasks are tokenization, as in given a sentence or a tweet, whatever. Okay, in this part of the tutorial, I will use the word document. Document can be a tweet, can be a Facebook post, can be a blog post, whatever. But I will just use the word document. So, given a document, it may be even a sentence, it needs to be tokenized into different words, or even multiple words can be a unit. Maybe someone says, maybe Mahendra Singh Dhoni. You can think of this as the three different words, but you can also think of this as one single named entity. So different kinds of tokenizations are there. Part of speech tagging, which words are nouns, verbs and so on, and named entity recognition. These are some standard NLP techniques or NLP tools which has its use in linguistics, as in you can figure out different so if you have a document with a sentence and the parts of speech are known, that can help you in some ways. For example, it might help you to understand which is the name of a place versus which is the maybe just an adjective about that place. Right. So these things can be interesting. Now, but the good part is that nowadays no one needs to build tools for these kind of tasks. Many such tools are available. For example, by the way, in this talk I am only focusing on English tweets, but we have discussed these points. Sarah was raising it. The similar challenges exist if you want to handle data in other languages, but more challenging. Because English text has good NLP tools, but if you shift to like Indian languages like Hindi or Bengali, then there are not so good natural language processing tools in other languages. But for this talk, I will only focus on English tools. So there are standard natural language processing libraries. Like Stanford University has, so there are lots of tools shared by Stanford NLP group. Then there is a dedicated natural language processing library for Python, NLTK, Natural Language Toolkit. As I said, we prefer Python for most of our programming, so we make heavy use of NLTK. And these tools will have, these libraries will have tools for the tasks that I showed, like part of speech tagging, recognition, and so on. However, it's also true that these standard natural language processing libraries have been designed keeping in mind formal English text, which will have a grammatical structure and so on. As we discussed before going into the break, tweets are very seldom written in a proper grammatical way. Right? So tweets are too short, and it uses informal languages, abbreviations, and so on. So these libraries, they are good, and surely they should be used. But they may not produce as good results on tweets as they do for formal English text. Therefore, some natural language processing libraries are being designed specifically for tweets. For example, CMU, Carnegie Mellon, the NLP group in Carnegie Mellon has given this part of speech tagger for tweets specifically. So the difference is this: part of speech tagger for formal English will give you nouns, adjectives, verbs, and so on. But it will not give you emoticons. It will not give you hashtags or URLs. But this particular part of speech tagger, specifically designed for tweets, it will also tell you this symbol is an emoticon, that is a hashtag, that is a URL, and so on. So even non-English parts of speech can be tagged. This is in Java. You can try that. Similarly, named entity recognition. Named entity recognition, for example, let's say consider a tweet. Okay, I'm intentionally giving this example because I'll come back to it later. So you say JFK terminal 2 damaged by Sandy. JFK terminal 2 damaged by Sandy. It might be Sandy is the mischievous boy who has damaged something in a building. It might also be that. But in the context of Hurricane Sandy, it means John F. Kennedy Airport Terminal 2 has been damaged by Hurricane Sandy. Right. So how to understand this? First of all, JFK is not the standard name of any airport. It's an acronym used in Twitter. So first of all, the first step, there are two steps. I will come to the second step later. First step is to understand what are the named entities in this text. So JFK is a named entity and Sandy is a named entity. Right. So named entity recognition is a very well known tool in NLP which helps a lot of other tasks. So again, there are lots of NLP called normal English text in those libraries which I mentioned, Stanford NLP or NLTK. But specifically for Twitter also lots of tools have been designed. In fact, this page, I was surprised to see this page myself. They contain about 10-20 papers just on named entity recognition from tweets. So it is a well-studied field of research, and I hope you can understand a research problem which has seen 20-30 papers means that it's not an easy problem. Otherwise, the first couple of papers would have solved it. So named entity recognition from tweets is not at all an easy problem because it's written in very awkward English or so on. In fact, okay, I'm making a statement here which might be wrong with that disclaimer. From the little experience I have had of seeing tweets related to different disasters, it seems that Indian people write more grammatically correct tweets than people from Europe or US. I mean, tweets posted in US are sometimes gibberish even to human eyes. Whereas tweets, I was seeing the tweets posted during Chennai floods and all, they seem more grammatically coherent. I might be wrong, I'm just speaking from very last time. Anyway, so this is an identity organizer for tweets. Another important kind of pre-processing is sentiment analysis. Right. So, as you can understand, to figure out the sentiment of a text or sentiment of a document. Now, some of you might be thinking quite naturally, in case of a disaster scenario, why is sentiment important? Everyone will be posting sad tweets. Who will post a humorous tweet in case of a disaster situation? So, can you think of why sentiment detection would be important in a disaster scenario? Okay, there are lots of other techniques, there are lots of other situations where it makes a lot of sense. For example, a new iPhone has been released. Are people happy with it? Maybe a Samsung has released a mobile phone. Are people happy with it? So our standard way is to go and ask people. But again, how many people can be asked? 500, 1,000? Rather, what Samsung would do, they would hire a social media analyst. Maybe they have already hired them. So they will just collect tweets containing the word Samsung or the brand of that mobile phone, and then we will do a sentiment analysis to see whether most people are happy with the product or sad. So that's one scenario where I can understand sentiment detection has a lot of potential. But in case of disasters, can you say a scenario where sentiment detection would make sense?
I can think of one or two situations. One could be possibly whenever disaster happens. Quite often, at least in our country, people are quite disappointed with the way certain infrastructure projects have been taken. Like in case of Chennai, people say that the water extraction system and those things were not taken care of while Chennai grew like anything. So people tend to, I would say, blame or express their frustration with respect to the government authorities, the administration, all those.
So whether people are happy with the relief efforts going on.
Yeah, that's another one.
But whether people are happy with what the politicians are saying, those things are definitely meaningful to politicians or maybe for planning the future relief efforts. So I would like to share a personal experience here. So when we started this project, I think in 2013 or something, So right at that point, this Uttarakhand flash floods occurred. And at that point, Twitter usage was not that much in India. Plus, that was happening in a remote location and not anywhere like Chennai and all. So we could not collect too many tweets. We collected around 3,000 tweets. And then I had no time on hand, nothing much to do. So I actually read through those 2,000 tweets. And I must say that the first few hundred tweets were very digital. Very sad and depressed. There was no food, no coordination. The government was not at all prepared, it seems. So there was no sentiment detection tool would be necessary to say that it was very negative sentiment was going on. But then after a couple of days or maybe after the next day, something started happening. The Indian Army took over. And from all reports, I think many of you know it better than I do, they did a fabulous job. So after about say, the first 1,000 tweets, I could see that people are expressing pride and satisfaction to what the Indian Army was doing. So it was a distinct difference from the sentiment in the first few hundred tweets or first few thousand tweets and the next few thousand tweets. I mean, and frankly, reading those tweets, I really felt proud of the Indian Army. They have, and frankly, I must say this, that maybe it's an exaggeration, but I don't think Indian people handle disasters worse than US people. US also couldn't do anything when Hurricane Sandy struck. Whereas there was this cyclone in Orissa, where the Orissa government did a very good job of removing people from the situation, the area where the cyclone was about to strike. So from these examples, what I have seen at least in social media, I don't think that Indian people are doing a worse job of handling disaster situations than. Sure, some disasters do catch people unawares, like the 2004 tsunami. That was unthinkable that scale of that, a disaster of that scale could have occurred. Maybe even in the Uttaranchal floods. But I think some organizations, at least in India, notably the Indian Army or the Orissa government in that case, they are doing a very good job. So for those kind of applications, sentiment analysis can be used.
So in this context, I can share one information. Recently, I was attending a lecture in IIST and on the same topic, like online social network, and perhaps the speaker was referring that in the recent attack, terrorist attack, the attacker over Facebook or Twitter or other social networking sites, they were celebrating. And celebrating, they exchange messages that they have been successful.
You mean the Paris attack?
Yes, Paris attack and other attacks also, as well. And that agency like American or European, who are responsible for finding that who are etc. They were analyzing those tweets and all.
So I agree with what Prabha was saying. Thank you for reminding me.
And that was of course a man-made.
So every time a shooting incident happens in the US, even last month there was a shooting incident, a huge debate goes on about the guns policy. The US has a very free guns policy, and it's well known that there are some political parties or some political ideologies which support that people should have access to free guns or it should be easily available, whereas the other political parties or other political ideologies say that no, guns should be very much restricted. So every time a shooting incident occurs, people collect those tweets and the government and they try to figure out what the public is saying. Like, do they want to have stricter gun control or do they have liberal gun control? So those kind of situations, the sentiment analysis tools can be very useful. Okay, so there are many sentiment analysis tools which have been proposed, and usually a rule of thumb to figure out whether so suppose you want to know whether a lot of research has already been done on a particular topic or a question. A rule of thumb to figure it out is there a paper which compares different methods? Or is there a survey paper? There is. So this paper, which was in person is Conference on Online Social Networks. It's a new conference, but it is becoming popular recently, and it focuses especially on social networks and social media. So so there was a paper in person 2013 which was about comparing and combining sentiment analysis methods. Very briefly, they found that no one method works best in all circumstances. Therefore, they proposed combining different methods. Right? And they have also made this system live. You can try out this. So, if you give some text input here, it will actually give you sentiment scores by different methods. And then you can combine them. Like you can take a majority voting. Say 5 things. So by the way, these sentiment analysis tools, some tools are just binary classifiers. Say they say positive or negative. But most of them give a continuous score. So 0 means completely negative and 1 means completely positive. They will give some score in between. So you can combine scores given by multiple methods. Okay. The next thing is geotagging or geocoding. This I actually stated a bit in the introduction. So some tweets have geographical information in them. So if you have a device which can know your latitude longitude, like a smartphone, a GPS enabled smartphone, and if you allow that device to give you your location in the tweet, then tweets can have geotag information, as in the latitude longitude. However, it doesn't help much because only 2% of register-related tweets are geotagged, and actually in India it's even lesser. So what is the alternative? First of all, why is this problem interesting? Let's take just one example. Suppose the place where the disaster has actually occurred, tweets coming from that place versus tweets coming from elsewhere. It's intuitive that there will be a characteristic difference between these two types of tweets. People who are in that region will post much more about what the situation is, whereas maybe people who are far away from that situation will just post sentiment and opinion and so on. So it helps to know which tweet is coming from where. But the problem is most tweets, 98% tweets do not have geographical information. Therefore, the alternative is geocoding. So that the text does not have any geographical information, but we will try to extract something. So, for example, one option can be extract named entity recognizers, extract named entities, and then map named entities to names of places. For example, suppose it says shooting going on near Halle. Halle is what's Halle? I mean, nothing. I mean, no standard tool will tell you that Halle is a place. Halle is one of the places in. Maybe I am pronouncing it wrongly. French words are typically difficult to pronounce, but the spelling is Halles. So I am just saying Halle. So Halle is one of the places in Paris where the attack was taking place. So one way would be to use a named entity recognizer, which will hopefully be able to identify that Halle is a named entity. And then there are lots of tools available, there are lots of public lists available in the web, which will give lists of geographical locations. You can pick up geographical locations near Paris, and then you might be able to match Halle with those kind of things. So that is one way. I am not claiming this is the best way, but that is one of the ways. So those were some about processing the data, like part of speech tagging, recognition, sentiment detection, geotagging and geocoding. As you will see, these tools are building blocks which can be used to solve these research problems which we are going to discuss up next. So at this point, any question? Okay, so let's proceed. So about the research challenges, I must say this is just a subset. There are lots of other research challenges, plus one of the important goals in research is to figure out new problems. So a set of research problems can never be exhaustive. We are expected to find out new problems. Even then, this is a list of problems which the community is focusing on much today. And again, I mean, sure, you are welcome to ask, but I mean, I won't be able to answer questions like, what is the best method for this challenge? Because that has not been established. Like classification, if it was well established that this classifier works the best, then research on classification would stop. But that is not the case. No one classifier has been found which works the best on all or in all data sets or in all circumstances. So all these problems are open. Some have been, there have been lots of studies on some, there have been lots of studies on, less studies on the other, but all of these are open problems. I must say another thing. So, as I said, there can be lots of different types of research challenges. One type of research challenge is figuring out out new machine learning or new NLP techniques. Like you saw, building a better named entity recognizer than what is available. That is a very well-known research challenge. There are lots of people who are trying to do that. But personally, I have not tried to, or I don't intend to try to build new machine learning or natural language processing tasks. Rather, our goal, or personally my goal, is to use these tools in order to figure out interesting information from the domain. And the domain is social media during disasters. So, till now I have not tried to figure out or tried to develop a better classifier program, or a better classifier algorithm, or a better named entity recognition algorithm. Rather, we use what is available to get interesting information in this context. Okay, so let us see these one by one. Feel free to ask questions. So, classifying different types of information. Again, there are different ways of classifying. One would be the type of content, like you said. Which tweets contain or which documents contain situational information versus which just contain sentiment and so on. The information source, what kind of users are they coming from? Media, NGOs, victims and so on. The location, whether they are coming from the disaster affected area or from elsewhere. Credibility, humor versus true information. All these are different aspects along which documents can be classified. So again, I am not spending much time here because from the several questions that I have heard during the break and also earlier, I understand many of you are familiar with classification. So very simply, we need a set of items. So supervised classification. We need a set of items for which the actual class is known. Some of these we use for training the classifier, and some of these we use for evaluating or testing the classifier. It's called training set and testing set. So, and this is the very basic pipeline of what we do during classification. Out of these, there can be different challenges. One challenge is this: extract features from the items. What kind of features to use for a particular classification. Another challenge is to build a better classifier or to build a better predictive model which will learn better from the extracted features. Out of this, I personally focus on feature extraction and selection. Right, so, okay. Maybe I should not put this here. Learning a good prediction model is also a very complex challenge, but I am personally not doing that. That is done by the people who are working on machine learning theory. So they are still trying to develop new algorithms. If you check the top conferences or journals in machine learning, like ICML, International Conference on Machine Learning and all, still people are trying to build better classifiers which will perform well with small training data and so on. Right? I am personally not into those. I focus on extracting features from the items. Let's take a simple example. Suppose we are trying to figure out this rumor or credible versus non-credible information classification. Do you think length of a tweet is a good feature to use? So I am trying to design a classifier which will classify between credible and non-credible information. Should length of tweet be used as a feature? Intuitively no, but you never know. Like maybe automatically generated tweets are longer than manually generated tweets. It might also be that people who are actually in that disaster affected area, they don't have much time to tweet, so they are posting short tweets. Whereas people sitting elsewhere, they are posting long tweets. So length might be a very important feature. These things cannot be known. Right? And often these kind of correlations are tricky. So let me give just one example which has nothing to do with disasters. This is just you can take this as a digression. So how does correlation affect classifiers? So one retail store in US, one retail store had a branch in a certain city, and they wanted to make that store more attractive to people who are living far away from that location. So they said, people who live more than 10 kilometers from our store, but still who come to us to shop, we will give them 20% commission or 20% less on the products. No harm in it. So this is a good promotion. 2 months later, so I think you know in US racial discrimination is a very sensitive topic. Like I can say here whites and blacks, but in US possibly these terms would be even bad. You cannot say whites or blacks. So 2 months after this promotion scheme was announced, one category of these started saying they are discriminating against us. When we go, they do not give us any less, but we can see other group is getting less on their products. Immediately there was a furor, the media started reporting and all, and they went back to this store. The store owner said, we never differentiate based on races. We just said people living 10 kilometers away from us will give them less. Then people did a meta-analysis and they found that coincidentally, that store was located in an area where most of the people living in the vicinity were from one racial group. So the other racial group, only they used to get the discounts because they are coming from far away. So geographical locations might not have anything to do with race, but such strange correlations do occur. And that is the challenge in extracting features. Sometimes some features which are not at all intuitive might work out very well. On the other hand, some features which seem definitely this will work might not work. So extracting features is a primary challenge. Then again, just to give another example, this is from disaster itself. So there was these studies which were trying to figure out situational information during disasters. The first one of the most well-known papers, what they did, they developed a classifier which used the words in the tweets themselves. So they said that situational information is posted in a more formal and objective way than other types of information. So they use natural language processing tools to figure out whether the text was being written in a formal and objective way. And they used words in the tweet to make this classifier. It worked well. But what is the problem? The problem is that classifier did not perform at all well when it was applied on some other event. Because the words, it got trained on the words related to one event. Say if you train a classifier on the Paris attacks and then test it on the Chennai floods, the vocabulary will be entirely different. One will contain places named near Paris, the other would be maybe Chennai names. One would contain shooting, bullets, terrorists, the other would contain flood, water, and so on. So that was the challenge of using words as features. So in one of our recently published works, therefore we have used some event-independent features. We have used some syntactic or lexical features which are not words. Right? So for example, we said that situational information should not have too many questions because these people are giving information. They are not, people who are in that spot, they want to give information, they don't want to ask questions. So we look for the presence of question marks. Then exclamations or things like, oh my god, or very sad to know that. This kind of subjective words, they are usually not found in situational information. So instead we focused on this kind of words and we showed that the classifier using these features perform much well than a classifier trained on words. So which features to use, that is a very well-known challenge in using classification, while classifying. And just one thing, that this testing set and training set, as I said, for both the actual truth needs to be known. So often we have just one set for which the truth is known. So how to separate it between testing set and training set? I'm not going into details, but one of the standard procedures is cross-validation. Say you use 90% of the, say you have a set of 100 items for which the class is known. You use 90 of them for training and 10 of them for testing. But the question would arise, which 90 for training and which 10 for testing? Standard answer is, make groups of 10 and use 9 groups for training and 1 group for testing and do it 10 times. Once with every group of 10 items is used for testing once. And then you report the average among all these. So this is for 10-fold cross-validation. Anyway, if you want to know some details, you can talk to me, but I am not spending too much time here. Okay. So that was about feature selection, the discussion till now. The other question definitely remains what predictive function or model to use. This is a challenge. Machine learning people are doing this. But for most of the research that we do, there are lots of classifiers already proposed. We just take one and use. Which one will work best? Not know. So, but the different classifiers work better on different data sets. However, good news is that these no longer need to be implemented because there are lots of machine learning libraries also available. This is a particularly useful one. Machine learning for Python is scikit. Scikit contains a lot of, implementations of a lot of classifiers and so on. So, if you learn to use this library, then you do not need to, you already have lots of classifiers in your disposal. Many of you might be using Weka. Weka is another such tool which already implements lots of classifiers. Okay. So that was about classification. The next challenge we will focus on is clustering. So clustering is basically the unsupervised version of classification. That means here the ground truth is not known. That means I said in the classification stage, supervised classification, you need to have a set of items for whom the category is already known. And you train the classifier based on those. In this kind of clustering, those categories are not known. So the goal of clustering is group similar items together so that items that you place within a group are more similar among themselves than items placed in different groups. It's a very abstract definition, but that is the crux of clustering. So, an application, as I said, there are hundreds of thousands of messages posted. It is not possible for human beings to read all of them. So this problem is typically called information overload. So there are multiple solutions to information overload. One of them is deduplication, which we saw. You can remove duplicate messages. Another solution would be clustering. If we can cluster related tweets or related documents into stories, then maybe human beings will not need to observe each document or each tweet. They can just focus on a story. So suppose there are hundreds of tweets coming, but many of them would be related to the same story. If you can cluster them automatically, then the human beings can only focus on those stories and not the individual tweets. So that's one application of clustering. Again, clustering is of many types. Two primary types is one which is a hard clustering, where each item is placed into just one cluster. So basically it gives a partitioning of the set. However, there are soft clustering techniques where an item can belong to multiple clusters with different degree. For example, you might say, suppose there is a tweet saying, suppose there is a tweet saying, 7 people are trapped in this area. I am feeling sad for them. This tweet both gives situational information as well as some sentiment. So maybe this tweet will go maybe 0.7 or 70% into situational information cluster and 30% into opinion or sentiment cluster. Right, so that's soft clustering. So the same item can be placed into multiple clusters. Again, there are many standard clustering algorithms. Sure, you are welcome to develop new ones, and if the situation permits, or the situation needs, then you might have to develop a new clustering algorithm. But there are lots of well-known clustering algorithms. The scikit-learn package also contains implementations of clustering algorithms. So not only classification, you can also use it for clustering. Now, one particular example of soft clustering has become very popular. That is called topic modeling. Basically, given a set of documents, figure out what topics are represented. Given a set of documents, figure out what topics are represented and which document is of which topic. What does a topic mean? Intuitively, we might think topic means politics, sports, religion, environment, but that is not the case. Because, like say in a disaster scenario, surely you might say there is only one topic, disaster. So that's not what we are after. Here topic means topic is also data dependent. For example, let's explain for example. So there was a study on social media posts during an earthquake in Indonesia. They used topic modeling on the tweets collected from there. And these are some of the topics they identified. So basically a topic is a set of words. In this kind of algorithm, a topic is a set of words which frequently occur together. So they found many documents or they found many tweets maybe which spoke simultaneously of tsunami and disaster or tsunami and relief or relief and earthquake. Right, so this group of words they were frequently occurring together. Not that maybe there was no one document which contained all the 4 words. That's not the case. It's not necessary that one document has to contain all the 4 words. But typically, this set of words are such that they occur much more frequently than maybe words from this group and words from this group. Right, so words within a certain group occur more frequently. If you remember, that's what I said as the basic goal of clustering. Group similar items so that elements within the same cluster are much more similar than elements occurring in multiple clusters. Or sorry, elements occurring in different clusters. So you can see the words placed in this group, they occur much more frequently, co-occurs much more frequently than words in this group and words in this group. And if you see, this group makes sense even to us. Like this topic seems to be about the actual disaster itself, tsunami, earthquake and so on. This topic is talking about dead bodies, missing victims and so on. This is talking about aid. So topic modeling has been found to identify these documents or these topics quite well. I can't say very well. So I have applied topic modeling on tweets. Some topics are absolute garbage. Even human beings cannot understand what this topic means. But then some topics make very well. They seem very good. So of course, in the paper you will only report the good topics. No one reports the bad topics in the paper. So in the paper the good topics only come out. So very simply, a topic, in case of topic modeling, a topic is a cluster of words which frequently occur together. If a document is assigned multiple topics, just as I said, maybe there is a document which talks both about the dead bodies as well as the relief being organized, and it will be put into both these groups. Maybe saying it belongs with 20% probability to this topic and with 80% probability to this topic. So these things are just pointing out. This is actually a very simple description. This is not the actual case. What actually is this. But I am not going to explain that. Maybe some of you know topic modeling, so you will understand. If you are interested, please talk to me after the lecture or during a break. I am not going to actually be describing this thing. Instead, I will just tell you the most popular algorithm for topic modeling is latent heuristic allocation, LDA in short. And again, there are lots of tools which you don't need to write your implementation of LDA. There are lots of tools which will actually do LDA for you. Okay. LDA is used quite frequently to figure out what the people are talking about. And see, sometimes, again, I must say there is no need to point out these resources. If you just go to Google and write LDA tools, you will get a much more comprehensive list than I am showing you. Okay. So we have discussed about classification and clustering. So one question can naturally arise, which one to prefer? Again, that's a very application dependent question. So suppose you are analyzing data related to an ongoing disaster in real time. Then you simply don't have the time to build up a training set. Because for building up a training set, you got to show some documents to human beings. They will first categorize, and then you can train your classifier and then run. This amount of time is not there. So maybe for real-time data processing, unsupervised algorithms are only one option. Also, it might be that the categories are not known previously. For example, the example I was giving a few, maybe half an hour back, that during the Chennai floods, a rumor began to be circulated that crocodiles have got free from the Chennai crocodile band and are moving around in Chennai. You cannot look for this class using a supervised custody, because no one would tell you that people would start talking about crocodiles during a Chennai flood. So for this kind of applications, clustering is the only way. Hopefully the clustering algorithm would be able to dynamically figure out that there is a new topic going around which is crocodiles, and then it will start tracking that topic also. So in these cases, real-time processing of data, clustering is the only option. However, there is a huge demand for supervised algorithms also, and that is what I was referring to maybe 10 minutes ago. It makes sense to train your algorithm on a past disaster and then to use it on future disasters. Right? So, suppose we now know that Chennai floods have occurred, we have data for that. Build up a supervised classification algorithm and train it on the tweets of Chennai. Hopefully, if another event occurs in future, your classifier can be used then in real time to figure out different classes of content. The challenge, of course, is features extracted from one event may not be generalizable to another event. Right? The example I gave, if you rely on the words, particular words being used during Chennai floods, maybe if there is a flood next day in Philippines, it will not work as well, because the vocabulary will be very different. Still, it's useful to have both clustering and classification algorithms. Okay, any questions? So it's 4:15 now. I think I require maybe 20 minutes more. So do we need another break or continue?
Continue.
So, okay, the next challenge is information extraction. So, as the name suggests, it means extract different kinds of useful information from within the content of a tweet. One basic example we have already discussed is named entity recognition. But, okay, so this is a very recent study. By the way, at the end I have a slide which says about the different conferences which you can target, conferences and journals. ISCRAM is one of the new conferences which focuses on disasters. Right, so ISCRAM, it's not as well known as other conferences which have been continuing for a long time, but this is very specific to disasters. So, okay, so in this study in ISCRAM 2013, so we are discussing information extraction. So we want to figure out particular types of information. Now, how that information will be written in a tweet can be very different. For example, the way in which, so suppose someone wants to report about number of people dead, versus someone else who wants to report about what building has collapsed. The way these informations are posted would be very different. So what this study did, they first categorized or classified tweets into different categories, like infrastructure damage, donations, auctions, etc. And for each category, then they did a category dependent information extraction. Like what specific infrastructure? So if you understand that a tweet is about infrastructure damage, they use a different technique in extracting information as compared to a tweet which they understand about maybe health or donations. So information extraction is in itself a challenge. Even if you, so the main challenge is that the same information can be worded in different ways or posted in different ways in the tweets. Another related goal is this semantic enrichment of context. You might remember some time ago I took an example, JFK Terminal 2 damaged by Sandy. This is a tweet, JFK Terminal 2 damaged by Sandy. Now, here, as I said, we can use names. So, suppose we want to understand what is going on. First of all, for someone who does not know what JFK is or what Sandy is, this tweet might not make even sense. It might well be Sandy is a boy who has damaged something. But then suppose you know that Hurricane Sandy is going on, even then JFK So suppose this information that John F. Kennedy Terminal Airport building, Terminal 2 has been damaged. One person can say JFK Terminal 2 damaged by Sandy. The other person can say New York Airport damaged by Sandy. Right? So somehow it would be good if you can figure out that these two tweets are actually giving the same information. JFK is the New York Airport. But then no natural language processing tool will tell you that JFK is the same as New York Airport. So what to do? People have figured out this technique of semantic enrichment of content. Named entities are first extracted and then they are linked to concepts. But concepts can be of different types. For example, concepts can be Wikipedia articles. So let's take this example. Suppose this is Terminal 2 of JFK damaged by Hurricane Sandy. You first extract this named entity JFK, and then JFK named entity is linked to the Wikipedia article on John F. Kennedy International Airport. Right. If you can do this mapping, the advantage is that in Wikipedia the concepts are already arranged in a hierarchy. So you can understand that John F. Kennedy International Airport is actually an airport. So if you get a second tweet saying New York Airport damaged by Sandy, you will be able to figure out that this is speaking about another airport only. So what was not obvious from the specific text will be obvious if you can map the text to higher level concepts. Because it is known that John F. Kennedy is a type of an airport. Based on the Wikipedia categories, you can figure this out. Right. So this mapping from named entity JFK to the wiki article, this again there are tools available for these, like Alchemy and OpenCalc. There are two tools which have been used in lot of social media research, not only in disaster situations, but in general these two tools are being used a lot in social media research. They help you to understand topics of documents, to link named entities to other kinds of concepts and so on. Okay. Summarization. I would have been happier if this would be the summarization of the tutorial and we would have ended, but unfortunately this is not so. That will come in some time. So this is about the research challenge of summarization. So again, summarization can be of different types. So I think all of us in our school days have written summaries. Right. So that was one document was given to us, and we were told to write a summary. That is also a challenge. Even now, automatically generating summaries or summarizing a single document remains a challenge. But now another different type of challenge has come into place. We have a stream of documents coming. Tweets, Facebook posts, whatever, but it's a continuous stream. And we have to do online summarization. That means we do not know what is at the end of the stream. What data we have now, summarize it, then wait for the new data and so on. So summarizing a stream or set of documents, this is the current trend in disaster situations. And again, there are different methods of